Welcome back, everyone, in the central room where we have all the technical discussions of the conference. So this morning we had some talks about threats and threats analysis, and today, so now we just after the coffee break, we are one final presentation on threats, and then we will move to the security of the next generation of connectivity. So for this talk on threats, I'm very happy to introduce Joonhyuk Park, that is a South Korean student doing his master thesis, and that will talk to us about towards automated threat modeling for space systems via the SPARTA matrix. So please, welcome to the stage, and the floor is yours. Please, to pass on the different slides. Please back.
Thank you. Thank you for having me here. Hello, good morning. I am Joonhyuk Park. I am currently a master's student in Korea University, School of Cybersecurity. And I am currently a researcher at Security Automation and Engineering Lab. I'll be speaking about this paper. This was accepted in SpaceSec 2026, which was co-located with NDSS. And the title is Towards Automated Threat Modeling for Space Systems via SPARTA Matrix. So before we go deep into the details of our work, I must first talk about the background and why we carried out this research. It all starts from why security and threat modeling is important in space systems. So in the past, security of space systems was met by security by obscurity, which means that we kept the specific architecture of our space systems and the requirements hidden from the public. This somewhat gave us a wrong sense of security that keeping something secret from the public will make it safe from malicious attackers. Well, today the space industry looks completely different. We now actively use commercial, off-the-shelf components and open source platforms in our spacecraft and ground systems. This shift has dramatically lowered the barrier to entry. It's no longer just nation states that are launching satellites, but also private companies deploying their own spacecraft into orbit. So with thousands of interconnected satellites and the widespread adoption of publicly available technologies, the threat surface has expanded significantly. So obviously, we need a more systematic and proactive way to secure our space systems, rather than just relying on the secrecy of the information. So the current paradigm in securing space systems is establishing regulations and adopting strong security standards. The examples you see on the slides, the White House released Space Policy Directive 5, and the Cybersecurity Management Requirements and Recommendations by ISO are examples that emphasize that we must consider security from the earliest stages of system design. Rather than treating security as an afterthought, these regulations or standards call for risk-based, cybersecurity-informed engineering methods, specifically practices like threat modeling. So threat modeling is clearly important for space systems. However, doing this manually is not easy. It is very time-consuming, and the results may be inconsistent. Especially in the era where AI-based attacker models are growing, we need measures to close the time asymmetry between attackers and defenders, where attackers can strike instantly, but defenders require careful review and verification of the possible threats before deploying countermeasures. This is why we need an automated solution for threat modeling. However, up to now, there is no threat modeling tool specifically tailored for space systems. If we were to use the existing tools for general purpose IT systems, which lacks space domain knowledge, we cannot identify domain-specific threats for space systems. And that is exactly where our research comes into play. Our team developed a domain-specific threat modeling tool for space systems by embedding knowledge of space into the Microsoft Threat Modeling Tool template. Microsoft Threat Modeling Tool, or TMT for short, lets users model their systems in a data flow diagram format and automatically identifies which specific data flows may be vulnerable to certain threats. By using a specific template, users can model their systems using refined stencils, which are system components, and derive potential threats accordingly. Let me now walk you through how we built the tool. We embedded space-specific threats into the template using the SPARTA matrix. We also integrated MITRE ATT&CK and defend knowledge bases to define the space-specific stencils and to link the SPARTA-based threats to them. This is an overview of how we carried out our research, and we will go into each detail shortly after I explain briefly about what these knowledge bases are. So the first one is the MITRE ATT&CK framework. The MITRE ATT&CK framework provides a matrix of TTPs, that is, tactics, techniques, and procedures against general IT systems commonly deployed in enterprise environments. Each TTP is mapped to related defend artifacts, or TTPs, from the SPARTA matrix. And the second one is defend. Defend defines what we call the defend artifact ontology, or DAO. In this ontology, an artifact refers to any object, such as a file, a process, or a network connection that can be targeted or compromised by specific adversary TTPs. The ontology shows the hierarchy of those artifacts and the relationships between the artifacts and the MITRE ATT&CK TTPs, as you see on the right side of the screen. And last but not least is the Space Attack Research and Tactic Analysis, or SPARTA for short. As we see from our paper's title, this is the key element of our research. This framework also defines a TTP matrix like the MITRE ATT&CK, but this one is specific to space systems, including the spacecraft itself and some of the ground systems. Each SPARTA TTP is mapped to related MITRE ATT&CK TTPs, which we used as logical links to the defend artifacts, as I will explain later on. Now let's get into the details of how we formed our template for TMT. We first refined our stencils for space systems. We identified an initial set of space components based on architectural documents from authoritative organizations such as NASA and known survey papers. We then derived properties for each stencil based on the DAO semantics. The reason why we incorporated DAO was because it provides a standardized way to describe what each component is and how it can be attacked, which is exactly what we need to connect our stencils to the threats later on. Since we were using the TMT as the base of our tool, we mapped all components to the fundamental DFD elements, which is such as process, data store, external entity, data flow, and so on. So this is what our stencil looks like in the actual tool itself. As you can see, each stencil has specific properties that users can manipulate as constraints when modeling their system to enable much finer-grained threat derivation. Moving on to threats, we next extracted threats from the SPARTA matrix. Specifically, each defined threat in our template consists of the SPARTA TTPs at the sub-technique level. So we now have the stencils with the DAO semantics embedded and the SPARTA matrix as threats. Now we need to link those two so that the tool can automatically identify which threats apply in certain instances of data flows. Since both knowledge bases, the defend and SPARTA, are mapped to MITRE ATT&CK, as I mentioned before, we use that as the bridge to connect the stencils to the threats. This is where our SPARTA, MITRE ATT&CK, and the defend logical chain was ultimately used. So this is what our threats looks like in our template. As we can see, each threat includes a threat generation expression used by the tool to actually identify the threats in the DFD. That is marked with the red box on the screen. Let me now demonstrate how our tool effectively identifies threats for space systems using a specific case study based on the Viasat hacking incident in 2022. In this incident, the attackers exploited a misconfigured VPN to access the CYSAT network management system and pushed a destructive firmware update to thousands of satellite modems across Europe. We modeled the architecture of the Viasat incident using the TMT with our template, and it automatically generated potential threat lists based on the SPARTA threats. These are the actual screenshots of using our tool to threat model the incident and generate a threat report. And in order to evaluate that this list is in fact valid and our tool works well, we follow the evaluation method shown in this slide. We first converted our threat list into MITRE ATT&CK TTPs for quantitative comparison. And then we compare the list to two cases. One is the ground truth list derived by threat modeling professionals, and the other is using the existing tool, the SecOps TM. This tool was selected because it derives threats at a TTP level based on a DFD model of a system. So from the results, our tool successfully identified all the threats that the experts found, achieving full coverage. But what is more important is that the threats our tool identified were space-specific and covered all threats that might have been exploited. General purpose tools like SecOps TM are structurally incapable of identifying such threats as they lack the domain knowledge required to recognize specific attack vectors. And that brings us to the conclusion. Like all studies, ours has limitations as well. Our tool may over-detect threats due to the generalized stencil architecture. As you see on the previous slides, it is very high level. Also, some threats emerging from the ground segments were not fully incorporated into our template yet. We are planning to extend our research by leveraging AI capabilities such as LLMs for automatic attack graph generation in the space domain based on the system model and the threat list derived from our template. So the contribution of our work here is that we propose the first domain-specific automated threat modeling tool for space systems based on a widely used threat modeling tool, the Microsoft TMT. And that to build it, we systematically integrated knowledge bases from professional authorities. And thank you for your attention. Before we wrap up, there's a QR code on the screen that links to a short survey. We would really appreciate it if you could take just about 5 minutes to share your thoughts. Any feedback, whether it's a question, a critique, or a suggestion, communication opportunities would be extremely valuable in helping us refine and advance this research. Thank you very much.
Thank you very much for your presentation. I let you have the QR code, and then we have also the second QR code for those who were not in the room this morning. There's this QR code for you to connect to the Connects Me app to write your questions if you want. Otherwise, I'm also happy to take any questions live. So if anyone has any question.
Do you see any future to probably use also the MITRE navigation tools that they have online, where you can also access different framework to do threat modeling? It's another way to do threat modeling, but I see a lot of potential of using what you did with SPARTA.
First of all, thank you so much for the your opinion, and that is actually related to our future work. This is our work. At this moment, it's just focused on Sparta, but we are planning to finer grain the threat derivation process by using other tools with the that is related to MITRE attack, since it's more finer grained, and that is, I think, very valuable opinion, and we'll look into it. Thank you.
Thank you for the presentation. My question was regarding the results of the detected threats. I was just wondering whether they are provided sequentially in terms of the first threats that are found to the last, or is it given like an importance, a gravity scale, in which case the most important threats are given first and then the least importance at the end?
Thank you so much for the question. And this specific tool, it doesn't really chain the threats in a order. So as you can see in the, for example, the unified kill chain, it goes from in through out, but our tool doesn't do that right at this moment. That is why for future work, we are working on the chaining those threats derived by our tool to formulate an attack graph. So that will be in a sequential order. And as for you mentioned how to evaluate the risk to the threats. Those are not yet incorporated into our template as well, but using the SPARTA matrix framework and the risk assessment, the risk point matrices that are available, we believe we can incorporate that into the work for the future work. Thank you.
Thank you for your presentation. When developing these kind of tools, our feeling is always that there is limitation in how well you can verify the outputs because of the lack of real-world data. Do you plan on providing some kind of a extra strategy to verify the output of this tool? I see we saw the example with the real case, but do you have a database of information or plan to implement a verification strategy that is based on past scenarios?
Thank you for the opinion. And we actually evaluated this tool across 4 major incidents based on the space systems, other than the Viasat incident. But as an academic pursuer, it's really difficult to get into the actual details of how those incidents were happened, and that is actually the main challenge of our work. And we are collecting those kinds of incidents to improve our verification process. And yes, that is our future work as well. Thank you.
Okay, thank you.
Thank you so much for your presentation. Have you also considered incorporating the SPARTA countermeasures into the tool?
Yes, the threats are, I believe, from my knowledge, the SPARTA threats, they are each individual threats are, each individual TTPs are mapped to the SPARTA countermeasures, and yes, we are planning for the mapping the countermeasures as well into our future tool. Yes.
Okay, I think there were a lot of questions. Thanks again for your bright presentation. Unless there is a last one that wants. Ah, yes, there is.
Thanks again for the nice talk. Have you or do you plan to publish the templates you developed here doing your work?
Thank you for the question. And we are still at the planning phase, but as the previous question, for the previous questions, we are having difficulties in actually verifying whether this is implemented in a correct way. So I think if we cross that major challenge, we can think about actually publishing this template where personnel from industry can actually use it. Yes, thank you.
Any last question? No. Okay, then thank you very much again. A warm applause for your presentation.